All right, here we go. This is the next lesson in Algebra 2, Unit 6, Lesson 5, Solving Exponential and Logarithmic Equations. Okay, so just in case you don't know, an exponential equation is an equation containing one or more expressions that have a variable as an exponent, and a logarithmic equation is an equation with a logarithmic expression that contains a variable. So basically for all these problems, and I only have 6 examples, okay? What you're going to do, so let me jot this down before we do the examples. I'm going to say, if possible, write each side of the equation with the same base. If possible, write each side of the equation with the same base. I said with, if possible, because it's not always going to be possible, and those are the hard ones. I believe that's example 5 and example 6. Okay, so example 1, we'll start off with a nice easy one just so you see how it works. You already have each side of the equation with the same base of 7. So the only way that's true is if the exponents are equal. So set the exponents equal and solve for x. Okay, so 3x plus 1 equals 4x minus 3. Subtract 3x on each side. 1 equals x minus 3. Add 3 and 4 equals x. Or x equals 4. Okay? Example 2, solve for x. So if possible, we're going to write each side of the equation with the same base of 4, because I can write 64 with the base of 4. So if I do that, I leave the left side alone. 4 to the 2 minus x power equals 4 to the third power. Okay? Because 64 can be rewritten as 4 to the third power. And now, since each side of the equation has a base of 4, I just set the exponents equal to each other. 2 minus x equals 3, and I solve that. Subtract 2 on each side. Negative x equals 1, which means x equals negative 1. And if you want to go back and substitute in the original equation, you can. 4 to the 2 minus x power.
Excuse the interruption. Any 10th grade student has not come down to the spine yet to receive their Chromebook. Need to come down now. Again, any 10th grade student in the building who has not received their Chromebook yet needs to come down to the spine now. Thank you very much and have a great afternoon.
Okay, I just had to pause for that announcement. So 4 to the 2 minus x power means 4 to the 2 minus negative 1 power, which is 4 to the third power, which equals 64. So go back into the original equation and check your work. Okay, now we're going to get a little more difficult problems as we go. Solve for x. 81 to the 3 minus 2x power equals 27. So can we rewrite this equation so each side of the equation has the same base? Yes, you can. Now, you have to figure that out on your own. There's no secret to figuring that out. And you have to try to figure out what number it is on your own, too. So in this example, you can rewrite each side of the equation with a base of 3. Because 3 to the 4th power is 81. So I can rewrite 81 as 3 to the 4th power. And I can rewrite 27 as 3 to the third power. Now, let me see. I have some scrap paper over here. We're going to use a property that we learned earlier in this class. So if I have, remember, say I have x to the mth power raised to the nth power, that equals x to the m times n power. So when you have a power to a power, you multiply. So basically what we're going to do is we're going to multiply the 4 times the 3 minus 2x power. But you're going to have to distribute. So maybe I'll write, I won't skip any steps because it's on video. I don't want people to get confused. But you're going to do 4 times 3 minus 2x. And you're going to distribute to get 3 to the 12 minus 8x power. Okay? Because I'm doing 4 times 3 minus 2x. 4 times 3 is 12, and 4 times negative 2x is negative 8x. Now each side of the equation has the same base. The base is 3. Set the exponents equal and solve. 12 minus 8x equals 3. Subtract 12 on each side. Negative 8x equals negative 9. So x equals 9 over 8. It's okay to get fractions for answers. You don't always get nice answers, as you've seen in this class. Okay. This one's harder to check over, but if you want to take 9/8 and replace it, substitute it in for x in the original equation, you can check it over. Okay. Because what's 2 times 9 over 8? 2 times 9 over 8 is 2.25. If you do 3 minus 2.25, you get 0.75. And if you do 81 raised to the 0.75 power, you do in fact get 27, which you were supposed to get. Okay. Example 4, can we write each side of the equation with the same base? Think back to this property from earlier in the year. I think it was, I said x, let's say to the negative m power equals a 1 over x to the m power. So, I know that 5 to the 4th power, is 625. That means that 5 to the negative 4th power is 1 over 625. Okay? 5 to the 4th power is 625. So 5 to the negative 4th power is 1 over 625. And now each side of the equation has the same base. Just set the exponents equal to each other and solve. X equals 4/3. Okay, 2 more examples. 7 to the 3x power equals 20. So can you write each side of the equation with the same base? No, you cannot. So here's what you're going to do. You're going to take the log of each side. Okay, so here's what I'm going to do. Take the log of each side. So on the left, log of 7 to the 3x power equals log of 20. Now what you're going to do is you're going to use the power property from last class the power property, where you take your exponent and you bring it out front. The power property. Let me see if I can recall that. Let me get some scrap paper right here. Okay, so here's the power property from last class. Okay, it went something along the lines of log of m to the x power equals x times log of m. That was from last class. So I take that 3x, my exponent, and I bring it to the front. Now think about it like this. I want to solve this for x. So I want to get x by itself. So I'm going to divide to get x by itself. I'm going to divide by 3 times log of 7. Okay, trying to get the x by itself. So I have to divide by 3 and log of 7. So I have it like that. Now you have to be careful, okay? So I'll show you how to do it on my calculator. My calculator has a log button. So I'm going to hit, I'll hit log 20 divided by, you have to do 3 times log of 7 before you divide, order of operations. So I'm going to put 3 times log of 7 in its own parentheses. 3 times log 7, close the parentheses twice, and that's your answer. I'll say x is approximately 0. I'll do 513. So you have to follow the order of operations. Make sure you do 3 times log of 7 before you do log of 20 divided by that, okay? So put 3 times log of 7 in parentheses. And then do log of 20 divided by that. One more. So for example 6, what you should do is add 8 to each side of the equation first. So I get 4 to the x minus 7th power equals 81. And then we're going to take the log of each side. Let's use the power property from last class. Let's bring the x minus 7 to the front. The x minus 7 comes to the front. Get the x by itself. So you're going to divide each side by log 7. Divide each side by log 4. So we have x minus 7 equals log 81 divided by log 4. And then what you're going to do is you're going to add 7 to each side. Get the x by itself. Okay, so what you're going to do in your calculator, right? You have a log button, hopefully. On my calculator, my log button is right there. So I'm going to hit log 81 divided by log 4 equals that plus 7. I'll say x is approximately, I'll say 10.17. And that's my answer. If you want to double check that in the original equation, you can. I guess that wouldn't be a bad idea, okay? Let's take our answer, subtract 7. Let's do 4 raised to that power minus 8 equals 73, perfect. Okay. And that is the end of that lesson, solving exponential and logarithmic equations.